Thanks, Sean.
Brilliant. Thanks very much, Laura. Welcome, everybody. Renita, if you can start presenting. So my name's Sean Gardner. I'm a Senior Technical Director at Calibre. I've been working at Calibre now for about 11 years. And prior to that, I was working at a number of other consultancy. I've been Christchurch-based since I graduated in 2002, I believe, was my first year of work following my graduation from the University of Canterbury just over 2 decades ago. So that's kind of showing my age. I imagine that some of you were just being born. But I've been very fortunate to be in the engineering profession. Obviously, 10 years ago, we had a bit of a bump, which has meant that I've been very busy pretty much for the last decade. And we're in a time in New Zealand's, I guess, engineering journey where there is just more and more work that needs to be done. And the input of engineers is highly valued. So it's a great time to be joining. We are around about 140 odd staff based in 9 offices across the country. From my perspective, I think that puts us in an ideal size. It means that we can pretty much take on any size project that New Zealand wants to throw at us, but we're also small enough that we can have a more intimate relationship, I guess, with our colleagues, with our peers within the office, within each of the offices, across the offices, and also with our clients. So it means that we have quite a flat leadership structure. While I sit on the senior leadership team at Calibre, me and my colleagues on the SLT, there's only below that there's kind of regional leaders, and then there's the staff themselves. So we have a very flat structure, and that means that the leadership team are readily available and accessible for kind of all manner of discussions. But it also means that we invite our staff to be involved in strategic direction and understanding what's happening in the marketplaces. And people, in my experience, have greater opportunities in this sort of size firm, because we get, as I said, the projects that you want, but also the opportunities for, I guess, rapid progression through the ranks are there, because the opportunities and the responsibilities are just given to those that step up and want it. I'll make sure I don't miss off anything of my little notes here. Yeah, so as I mentioned, we've got the 9 offices across the North and South Islands, Auckland, Tauranga, and then coming back down the line, we've got Wellington, Masterton, and New Plymouth, and then in the South Island, Nelson, Christchurch, and Dunedin. So we've got, I guess that kind of means that we're local. We get to know what's going on in the local industries. We know we're part of the community, but that also means that we're not far away from all the work that happens. So we've got projects happening all over the place, and I'm fortunate enough to be actively involved in some very exciting projects in the North Island at the moment, including 3-story CLT over concrete podium for a retirement village in Tauranga, and a 40-metre high bay warehouse in Auckland. You can see there's a lot of words, probably breaking all the rules with the presentations in terms of too much text on a presentation slide, but you get the gist. Structural engineering, civil engineering, and surveying are our core disciplines, but we also have a strong advisory arm, and certainly we are looking for graduates who have what we call an advisory mindset. So these are those that are not looking just for the technical solution, but actually understanding what the client's issues are, getting to know the client better, and making sure that the solutions we provide meet their problem requirements, not just the technical solution that we think they need. Yeah, thank you. Moving on to the next bit. Some key observations about graduates entering the workforce and how this impacts the work environment. I guess as a graduate, you will find very early on that there is a lot to learn. the first few years out of university, you will find a very steep learning curve and coming up to speed with the, I guess, work practice. So we're a professional consulting engineering firm, so keeping a track of your time, making sure that it's efficient and that you meet the deliverables and communicate how you're going, where you're at, what needs to be done effectively with the project managers and those in your team, understanding where to go to for support, and in some cases, coming up to speed with not only the design standards, but also the design tools that we have to assist in those designs. And I think, I mean, without jumping onto my next point too fast, this is really where the benefit, I guess, for us as a consulting firm is, but the benefit that graduates bring is fresh ideas, is fresh blood, is understanding the latest research that's being done in the industry, in the universities, what's the topic of choice, grabbing that innovation and the research that is being developed at the moment and bringing that into our workplace, into our practice, is really the best thing that you can do. So finding, I mean, I know that a lot of you guys are now programming in computer software to, I guess, in addition to the core basics of engineering study, so understanding the material properties and understanding structural analysis of those components. That's all well and good, but being able to use those tools when you're exposed to the way that we do things, the way that we've always done things, this is what we want you to do, is to challenge those ideas, to say, look, the way that you're doing that is dumb. There's so much better ways now, and that's what we're looking for. We're looking for those better ways, the smarter ways of doing what we've done in the past better, faster, more efficiently, more accurately, with lower risk to us and our clients than what we've ever done in the past. And that's an opportunity that we've got now. Basically, you can use computers. I mean, who knows? In the future, consulting engineering is probably going to change from the nuts and bolts of how many M12 bolts do I need here, or what size weld and what size gusset plate, because a lot of that will be automated. The smarts will be around using that knowledge to better advise our clients. So again, that's why it's really important for me and for our business to have an understanding of engineering principles, have an understanding of the technology and the technical issues that we face, but being able to bring those in a real practical way to solve our clients' problems and offer them new and innovative approaches to the same problems, but again, just through a new lens, and making sure that that lens captures the latest research, captures the latest ways of doing things. And if we design a new app or a new software program or a new way of doing things through automation, through parametric design, through incorporating all of this technology into the way that we do things, it really gives us a competitive advantage against everybody else and sets us apart from those in the industry. And I'd like to think that we're not afraid of these particular kind of I guess challenges and opportunities that we have in front of us, because that's what our industry needs. We don't have that. There's only a limited number of engineers coming through university. There's only a limited number of engineers in the country, but the amount of work that we have to get done is never ending, and probably growing exponentially. Well, I think I pretty much covered off all my notes, but just to finish, I thought it would be useful to maybe, I guess, give some tips, some advice if I was in your shoes. So my advice is to get involved. So get involved in the office that you join, in industry. So getting involved in, if you're in structures, the Calibre structural group, getting involved in networking opportunities with your peers that you currently have, as well as industry. So getting to know the property council, working in specialist technical groups. So if you're particularly interested in earthquake engineering or structural engineering, or if you want to have more of a general practice understanding, all of these are specific technical groups that you can get involved with. and I encourage you to do so. There's a lot of young engineering networking groups as well, so that you can share what you're learning in the steps of your early career with those of your peers, and I guess share learnings and get a good understanding of where the industry is going. So I guess with that, there's networking with your clients, with your peers, but then also with your clients. So we will encourage you to get involved early. We like to get people in front of clients, and certainly in front of their client organizations. So where the senior leadership team might be meeting with their leadership team, we've got people who are engineering graduates working with architectural graduates and mechanical engineering and surveying, quantity surveying, all of the components of a design team. We need to have those touch points at multiple levels across the industry, relationships with them, but also it's your future, because the people that are going to be running the engineering firms of the future and the architectural firms of the future are the people that you meet and work with today. I'd encourage you to get exposure and get to work with as many engineers as possible. So we are fortunate enough to have, I think, in excess of 20 chartered professionals. So get to talk to all of them, get to pick all of their brains in terms of the way that they approach solutions. We've all got different ways of coming up with a solution, but because we've all come from different backgrounds, we've all come from different experiences, the solutions that we come up with are varied. And I'd encourage you to get the most out of learning from as many engineers as you can. Get exposure to different types of buildings, get exposure to different civil engineering structures, building structures. If you're heading more down the civil engineering route, different types of pavements, different geotechnical conditions, different environmental conditions. Just get that breadth of knowledge. If you're focusing on structures, don't forget about the other disciplines. Make sure you understand geotechnical issues. Make sure you understand civil engineering issues, infrastructure around stormwater, sewer, making sure that you've got appropriate levels and treatment. All of this is, it's really important to have a holistic understanding of knowing where you sit in relation to the rest of industry that you're sitting in. I'd also encourage you to understand fire engineering issues so that you know how the structure and the fire will work together. Use LinkedIn. We use LinkedIn. Apparently, that's the tool of choice at the moment. So if you want to know what's going on and understand where we are and what we're doing, equally, it's a tool for yourself. So you can understand and promote and get involved with companies and industries and events that interest you, and it just pulls that whole networking piece together. And my final little piece of advice is early on in your career, record your CPD, so continuing professional development. You will be given opportunities for learning. Make sure you record these, and also your what we call graduate work history summaries, but the projects that you'll work on. So one of the roles that I also do is I'm a practice area assessor for Engineering New Zealand. And so we encourage our staff to become chartered professional engineers and support them in the process to do that. And some of the key evidence that you will need to become a chartered professional engineer is to make sure that you've got sufficient, as I said, continuing professional development. So understanding the technical sessions, the training, the courses that you go on and are exposed to, and also capturing the graduate work history summaries that you do. So the work that you're working on, and specifically what you're doing on those projects, and how those demonstrate the various competencies that you need to get chartered. So that's me. I'll now pass on to Renita.
Hi everyone. So my name's Renita, and I'm the Senior Talent Acquisition Partner at Calibre. So I'll just be giving you a bit of an overview of the graduate program. So I'll tell you a little bit about what that's all about. And if you have any questions, just feel free to ask me as I'm talking. Happy for you to shout out if you want to. So yeah, at Calibre, we have a graduate program that runs over 2 years. The program involves both, or includes both, our Australian and New Zealand grads. So gives you a chance to interact with them and get to know them and learn and work with them, which is great. And actually prior to COVID, we did have our New Zealand grads actually traveling to Australia for the orientation day, but because of COVID, everything had to be virtual, which was a shame, but we're hoping from 2023 we can restart that again and get our grads flying over there, meeting everyone and having that face-to-face orientation. So the 2-year program, the aim of it is to help you develop a diverse range of skills and knowledge that we think will help you build the experience you need for a successful and long career in engineering. So we're hoping we'll give you all of that. So this program, coupled with obviously your on-the-job training as well, which is what you do day to day within your team. So in the program, we start off by getting you established. So the program normally kicks off with virtual development sessions, like personal branding, networking, and communication workshops. So those workshops will help you develop critical self-awareness and help you gain an understanding of the core principles and values, which we think you'll need to help yourself transition into the workplace. So we start off with those sort of workshops, and then we move into workshops that will help you build your capabilities. So we'll look at developing your professional and your technical skills with sessions on things like writing winning technical documents, safety and leadership, advanced presentation skills, and other courses like those. And then towards the end of the program, so at the end of the 2 years, we'll match you with a mentor who will support you through your career at Calibre and help you transition from that graduate to sort of a more experienced engineer. So they'll be there after that program to really, help you and guide you and be there for questions and all that sort of stuff. So if you look at this next slide, this is an example of our graduate program. So this is year 1 of the program. So this is what our 2022 grads are going through at the moment. So you can see there's a mix of those courses that I mentioned and also activities as well. So we normally have a plan that's set out for the year with dates, and so you know what's coming up. And when you join, you'll get sort of like a bit of a brief on each of the sessions, so you understand what you're going to achieve from each of them, and there's pre-work and things like that. So at the end of the year 1, there's a bit of a celebration, and then you move on to the next year, which has a similar sort of program as well. So that's a bit about the program. Does anyone have any questions about that? No? Okay, well, I've attached in the chat, I have attached a brochure as well that we normally would have handed out if we came to the career fairs in person. So you can have a look through that. That's got a bit more on the program. And at the back of the pamphlet, there's my contact details are on there in case you wanted to ask any questions as well. If you can't think of any now, you can definitely ask me them through email or giving me a call. But yeah, I'll hand over to the next person, which is Will. Are you there, Will?
Yep, I'm here.
So Will is one of our engineers in our Christchurch office. So yeah, go ahead, Will.
Thanks, Renita. So like Renita said, I'm an engineer, structural engineer in our Christchurch office. I was at Canterbury, graduated from Canterbury just over 5 years ago, and joined Calibre straight out of uni, and still here and still loving it. So I guess this is a bit of a slide that we've presented at uni before in terms of helping grads transition into the workforce. So ideally that'll be with Calibre, but hopefully there's some bits and pieces you can take out of here that you can use wherever you end up. So I guess first off, talk about transitioning to the workforce. When you turn up in an engineering office, it can be quite daunting. You might think that everyone around you seems to know exactly what they're doing and what they need to do and how to do it. They don't worry about it. Engineering is a complicated thing. You're not going to know immediately how to do everything that gets presented to you. So take your time, think it through, but then make sure you aren't afraid to ask lots of questions. At Calibre, I know you get buddied up with someone that's kind of the year above you. they grade the year above you. That's an awesome kind of first touch point to have someone to talk through, someone to make sure that, I guess, you're not asking stupid questions, but yeah, also then they know kind of how to frame the question and who you can ask that question to. I guess, like Sean mentioned, at Calibre and at most engineering offices, there's going to be lots of people that have got a whole range of different experiences. They know so much more about engineering than you do straight out of uni. So don't be afraid to kind of tap those people on the shoulder, take them aside and try and pick their brain, get them to explain things to you, make sure you understand it. So that engineering, you're going to continue learning throughout your career. It's not something you do 4 years at uni and you know everything. So make sure you take that opportunity to learn from all of the different engineers around you. Another thing, I guess, is that at university, a lot of the focus is on the technical skills. I know when I was there a few years ago, there was one kind of ethics and project management paper, but most of the rest of it's on technical stuff. Being a good engineer and a good consultant obviously takes a good understanding of the technical skills, but it's not just about that. The soft skills, the ability to communicate with people, kind of form that relationship with people is also crucial. So you're going to build relationships with your peers, clients, contractors, other professional service consultants, like a whole range of different people from all over society. So being able to kind of build that relationship with people and communicate clearly with them is something that you also want to work on. My next point on that was getting to know everyone at the company. Calibre, I have found in the first 5 years I've been here, has been awesome for that. Something I really, really love about Calibre, and that was such a flat structure that the senior leadership team aren't that many steps away and they're really approachable. I know on kind of my first day at Calibre, I had Sean, who was national head of structures, sitting about 3 desks away from me, and he's kind of always there and always available to ask questions to, and will take the time to explain it to you. And the rest of the senior leadership team are just as approachable, and that's something that I really, really recommend about Calibre. But wherever you end up, kind of making sure that you've got the ability to talk to those senior engineers and that they're going to take the time to help you. Because like Sean mentioned, I guess having fresh graduates at the company is great for the company. And so, yeah, just make sure that wherever you end up, that the senior engineers are going to take the time to help you out. And if you end up in a situation where they're not that interested in helping you learn, I guess I'd recommend starting to look for other options there. Kind of more from a technical structural engineering point of view, I guess one of the things that's key out of university is to kind of think about the concepts at a higher level as well. Try not to get, and it's very easy to do, is to get stuck right into the nitty-gritty detail of the numbers of a really specific point. Try and make sure you always, before you start anything, take a step back and look at it from the bigger picture. It's definitely something that takes time and practice to do, but kind of being able to do that and look at things from that higher level will help you understand so much more about where that fits in globally within the project that you're working on. And that will help you kind of add value to the project as a whole. Like Sean mentioned before, that's kind of stepping towards that advisory mindset of being able to kind of understand what you're doing, but also where that sits in relation to the wider goal and how you can improve the wider goal rather than just doing your piece really well. Another thing I would mention is make sure you become a member of Engineering New Zealand. That's really helpful. Student membership's free. If you come to Calibre will pay for your membership, but there's just lots of stuff through there that can make it much easier for you when you're working, and also gives you access to training and networking seminars and young engineering events and all of those sorts of things. kind of some opportunities to look out for when you're working as a grad. Construction monitoring. It's awesome to be able to get out of the office as an engineer. I know some professions, you start working and you're stuck in the office for your 40 hours a week, every week for the rest of your life. As an engineer, we're kind of lucky we don't have to do that. We can get out on site, we can see how things are being built. You can see potentially issues with the design, or how it was going to be put together, or tolerances and all sorts of typical things on site. And that really helps grow your understanding of engineering and makes you a better engineer, more well-rounded engineer. So if you get the opportunity to go out on site, I'd recommend that. If you can, travel as well. Travel around the country. If you work for a company that's got offices all around the country, if you can get around and meet people, meeting people face to face is an awesome way to get to know them really quickly, and because that'll build your network. I think, like Sean mentioned it, the people that you meet now as graduates in 10 or 20 years, they're going to be the people running teams, running companies. So building that network now when you're a grad is an awesome opportunity. Another opportunity to watch out for is if you see something or read about something that interests you, then speak up. There are lots of cool things going on that not everyone's all over at the moment, but if you find something that interests you and you want to kind of look more into that, for example, like mass timber structure design, if that's something that really interests you, speak up, and the company will find ways to kind of channel you towards some projects that let you really explore those interests. You don't have to get specific in one area, but if that's something you want to do, definitely speak up and let people know, and they'll find a way to make that happen for you. A couple of key pieces of advice I've got just for when you start out as a grad. One would be to hold on to your textbooks and your uni notes. They're actually really helpful, and you will go back and use them. So kind of hold on to that stuff. I know it can be cathartic, I guess, to throw them away at the end of the year, but if you can, hold on to some of that stuff because it is pretty useful. The main one, I guess, would be, though, is to kind of encourage feedback from everyone around you. All feedback, both positive and negative, is good. And so if you're not getting feedback, you're not going to grow as an engineer. So wherever you can, encourage feedback from your peers, your manager, the seniors at work. Yeah, just always encourage that feedback. The slide we're onto now is just a few projects that I've worked on while I've been at Calibre. So I'll just give you a really quick summary of them, and then we can move on. So the top left is the brick building, and that's the new convention centre in the background getting built around it. So you can probably tell that photo's a couple of years old because the convention centre's pretty much open now. But that building's called Isaac House, and on my second day at the company, I had Sean come over and ask if I wanted to help him out on that project. So that was kind of a cool strengthening fit out project that we did for that building. And yeah, that's one that I really learned a lot on, getting involved on my second day at the company. Top center kind of is the Akaroa Wharf. So the Akaroa Wharf is a project I got involved with by saying yes to something that I wasn't sure if I knew how to do. So we have got some really good wharf experts around the country, and we won the work to do the maintenance assessment on the Akaroa Wharf, and it was kind of one of those slightly out of the box things for me, but I said yes at the time, and it's led to me being able to be involved in a really awesome project, and kind of helped develop the way that that wharf is going to be rebuilt and replaced in the next few years as a community asset that can benefit Akaroa for the next 100+ years. So that was an awesome project that I was lucky to be involved in. The bottom left is project out at Littleton Port. So we designed these reefer towers that they stack refrigerated containers up against. It's a massive capital works project for them. It's helped them expand massively, and it provides them with a much safer way of going about keeping their refrigerated containers cool while they're waiting for them to be loaded onto the ships, rather than having to have people on the ground down and around the containers. They can walk safely up and down these towers, plug them in without having the risk of that man and machine interaction. So that was stage 1 of the towers. We've designed stage 2 very recently, and that's starting construction works at the moment. That photo there was from the opening of stage 1. Centre bottom is a project I'm working on at the moment down in the University of Otago, their food science department. So we're strengthening 2 existing buildings and building 2 new kind of add-ons at the end of each one of them. So that's got a stage 1 detailed design issue at the end of this week. So that's been a really awesome project, getting to work on a 5-story concrete moment frame building. And on the right hand side is a construction photo of a job I designed about a year ago, a large warehouse in Hamilton. So it's 80 metre span by 115 metres long, a 2-story office attached to the side of it. So you can see the 80 metre span portal frames in the background, and then there's the reinforcing in the foreground for the office which is happening tomorrow. So that's just some of the projects I've worked on. Yeah, I've had the opportunity to work on a whole range, which has been awesome. But yeah, that was kind of some highlights. So I think that's all I've got. I'll pass back to Renita.
Thanks, Will. Well, yeah, that's pretty much the end of our presentation to you guys. So we're open to take any questions if you all have any. Yeah, so just shoot.
I just had a quick question for Sean. Where you touched on quickly the changing need for using software solutions and new technology. Do you have some examples of challenges you've solved with new solutions or innovation, and how you went about developing those?
Well, I mean, at the moment, we're kind of limited because we've got guys like me who, when I went through university, the most advanced we got was a macro in Excel. So it's taking those sorts of, I guess, fundamentals and expanding them into some of the solutions to the problems that we have these days. So some of the designs we do are quite iterative by their nature. Looking at rocking solutions, understanding how the level of pre-stress will affect the overall response of the building, understanding how what that means in terms of apportioning the distribution of resistance between essentially an elastic system and a ductile system. So if you're working in parallel with a mild steel system which is yielding tension and compression, say external dissipators or some sort of external damping system, and then you've got another component of it in pre-stress, because of the nature of that design ends up being quite iterative. Those are the sorts of problems where I can see a technological approach to the solution would be really helpful, because you can change one parameter and the rest of the design will carry on through. So essentially this is a parametric design whereby you'll be setting up a system of variables and how they influence each other to come up with an optimized solution. So I know that the technology exists, I just haven't seen it adopted into what we do day to day to make what we do day to day more efficient.
Cool. Just for that answer, I just had so if someone had a innovation that was, say, outside of just optimization and making some fancier version of the spreadsheets that you have for design, how would they take that to someone in your team? And would you guys accept that?
Oh, we are always open for ideas. If you've got an idea, bring it forward. We've had engineers in the past. One of our engineers developed a slammer software tool. So for those of you, so a simple lateral mechanism analysis. So the first step of a detailed seismic assessment is to undertake a slammer. So essentially to try and understand what the limiting mechanisms of a building is. And that particular engineer had developed the software to quite a state whereby, so essentially it's a pushover analysis, but it determines the limit based on the, it was focused on reinforced concrete, but you can use that to come up with what is the mechanism that happens and then what is the force displacement relationship of it. So the idea for that was to actually get it professionally developed. At this stage, it's kind of set on the shelf, that particular example I can think of, but that's because the other systems and tools have kind of overtaken it. But it's an example whereby if you get in there early enough and come up with these ideas and bring them, then there's no reason why these can't be commercially developed or as a new revenue stream for the business or however it gets shared. So I mean, if people have got smart ideas, then we're all ears.
Cool, thank you for that.
I mean, some other things that I'm aware of that have been developed, just on a basic scale was, or at a basic level was development of a 5x5. So when we attend sites, we encourage our staff, well actually we require our staff to undertake a 5x5, which essentially means that you take a moment to have a look at the hazards that are on the site and take a note to record them and make sure that they are in line with what your assumptions were in the safety analysis that you had done before you attended site, and if there are new hazards, how you're going to mitigate them or work with them. And that was developed into an app and is now accessible through the Android store. So that we're open. We want to hear from those. What's the best way of introducing this and making it accessible for our staff in an efficient way.
Cool.
Thanks, Angus and Sean. Is there anyone else who has any questions?
That was a great couple of questions, Angus. My name's Mel. I'm one of the career consultants at UC Careers, and my connection cut out, so I apologise if you've covered this, but I'm just wondering, how many staff do you have at Calibre and how many graduates do you take on each year?
So we have around 130 employees at the moment, and this year we're taking on around 11 graduates across civil and structural engineering. So in the civil space, we are also taking on transport, water, urban development, and surveying and surveyors as well. So yeah, those are our opportunities. And what I'll do at the end of the session is I'll just pop a link to our job ad on the chat, so that if anybody here is interested in applying, you can go ahead and do that. The location on the ad will say Christchurch, but we are considering candidates for all across the country. So just in your cover letter, write which location you're interested in. And yeah, when that comes through, I'll have a look at it.
Great, thanks, Renata.
Any other questions?
Renata, could you maybe pop your email address in the chat just in case people want to ask any further questions?
Sure, yeah. So I'll pop my email address in the chat. Like I said before, there's a brochure in the chat if you have a look at that now. So that's something we handed out at the Auckland Career Fairs in person. So we've got a digital version that you can have a look at as well. And we would normally give out something in person if we were to come. So we've got some calc pads which we'll send across to the university. So I'm sure the uni will let you know where to get them. So just watch out for that email and then get yourself a calc pad as well. Great. Well, thank you for your time, everyone, and hope to see some of you apply soon.
Thanks, team.
Thank you.
Thank
Thanks,
you.
guys.
Bye.
Uh,
Yeah.
Cool. Thank you.